Good morning, class, or good afternoon, whatever time it is. All right, Mr. McCray here, trying to do another video on multi-step and both sides of equations, equations and solving them. Okay, so there's a couple things I want to go over to make sure that we're clean on. Okay, and then we will start some of the problems. Okay, so using multi-step equations, you're going to be using different techniques, and I'm going to show you a new technique that you could possibly use to simplify or solve an equation. And I think it's kind of counterintuitive, but I think it's a good opportunity to show you guys a different technique. All right. So some of the techniques that we're going to be working with on the board here. So the first one we have is the inverse operations. We already know how to do that. We know that the operation of that plus is equal to minus. Minus is the inverse is plus, and on versa. And then the last one is square root to x squared, and x squared to square root. Okay. So we're not going to talk about those. Those are like 10th grade stuff. All right. Next one is CLT. We call that CLT is also combined like terms. Okay, combined like terms. So how do we combine like terms? So let's look at some of the examples that I have here. So the thing about combined like terms is you always have to have the same properties in the numbers and the variables to make them to be able to combine them. So if you look here, we have 7x, or the coefficient 7x. So that means we have 7x's here. And then we also have 2x's. So therefore, these have the same properties to each other. So I can combine those terms to make negative, we have 7x minus 2x equals 5x. Okay? Same thing here. We have the whole number 7 minus 2. Those have the same properties because they're both whole numbers. 7 minus 2 is equal to 5. So that we can do that. Now here's some examples of not like terms, okay? 7x minus 2. Okay, 7x has a property of an x in it, but this 2 has a property of a whole number. So therefore, this cannot be combined to each other. So this would just be the expression of 7x minus 2, okay? The next one is another situation that you possibly see. You have 7x minus 2x squared. So 7x minus 2x squared. So these cannot be combined either because the fact is we have 7x's, and we're minusing 2x squares. So they don't have the same properties. X and x squared don't have the same properties. So therefore, these cannot be combined as well. Okay? So that's very important. Combining like terms. We're going to show a couple problems like that as well. Okay. So the other one is distributive property, or we call DP. So again, CLT, DP. DP basically means if we have a parenthesis around here and we have a value on the outside, we're basically going to distribute our 2 to everything in the parentheses. So we're going to multiply everything by 2. So that's going to give us a new expression of 2x minus 8. The same thing, we have negative 3 to the power of x times x, negative 3 times negative 6. So that becomes negative 3x plus 18. So I think we've done that distributive property before, so we're going to be pretty good. Okay, so those are the 3 techniques. Now the last one technique is called reciprocals. Okay, and it's a new technique that I kind of want to show because I think it's pretty cool way of solving these type of problems. And some people might be able to do it, some people don't. But again, it's going to be a new technique that I'm going to show you. I'm going to show you in a couple of problems. You can use it if you don't want to. Again, you don't have to use that style of work. Okay, so these 3 on the top will take care of any problem that you have to do in terms of equations. Reciprocals can be done if you only have distributive property, okay? Only if you have distributive property, but I'll show you what I mean in a second, okay? So again, these 3, you can do any problems that they come about. You only can use reciprocals if you have the distributive property, okay? All right, let me move on to the next page and let's talk about how to solve these problems. Okay, so the next page. So here is a couple examples here that we're going to do. All right, so the first example is negative 2 plus 3x plus 3x equals 10. Okay, so on here I have a little board of the operations that are involved in this. Okay, so again, what we're saying is I'm just going to write down the list of those operations. Okay, so we can get good at that, but you don't have to do that on the work. Just go ahead and solve the problem as best you can, and like I said, we'll work through it and try to help out any questions you have. All right. So let's look at the first thing. We have negative 2 plus 3x equals 10. Okay, so does anything in here have the same properties? Yes, the 3x and the 3x, both of them have an X on the side of them, so they have the same properties. Okay, so I'm going to check them off. All right, so I would have to use to solve this problem. I would have to use CLT. If I can write it, come on, baby. CLT. Okay, so combine like terms. So I'm going to write that down as an operation. CLT. Okay, so after I do that, so I have 3x plus 3x. So I'm going to keep negative 2 plus 6x equals 10. Okay. Now, what's the inverse of CLT and combine like terms? There is none. So that's NA. Okay, so again, that's just the operation. There is no inverse of that. So that's not applicable. Okay, so let's look at the next step. What do we have to do to solve this problem? Okay, so I think we know how to do that. So the first thing is, okay, what's the operations that we need to do to actually find the answer? So first is we say, okay, how do we find x if we put in a value for x? How would we figure out the answer? So say if I put 3 for x, then it would be 6 times 3. So that would be the first thing. We'd have to multiply by 6. And the inverse of that would be division. Okay? Next is we would have to minus 2 from whatever that value is that we found here. So I'm going to say minus. And then I'm going to say the inverse of that is plus. Okay? So when we do the regular operations, we go downwards. So we can do that. Whoa. Okay, and we go downwards. Now, when we do the inverse operation to find out what the value of x is, we got to go upwards. Okay, so let's do that. Negative 2, so we got to add 2 to both sides. Okay, let's add 2 to both sides. Okay. Okay, so this cancels. Okay, that's the first thing we do. So we have 6x equals 12. Okay, now what's the next step? So we have to divide by 6 because that's what the next step is. So I'm going to divide both sides by 6. And that's going to give me x equals 2. And that would be my answer. And that's how we would do it. So again, CLT, then again, that has no inverse, multiply, and then subtract. Go the opposite way for inverse, add, divide. No, not applicable in the combining like terms. There's no inverse for that. Okay, that's it. So that would be the answer. So let's do another one. So on this one here, I'm going quick because I think we kind of get an understanding of this. So I just want to go quick and show people, and then we can move on to some harder questions. Okay, so let's try this one. Okay, so we have 2, and again, what do we have to do here? We have to use distributive property, so dp. Okay, we're going to have to use the dp because again, we have the 2 on the outside, and we multiply everything through. So the operation would be dp. Okay, and then there's no inverse for that, so we're going to say na. There's no inverse for that. Okay, so if I do that, so that'd be negative 2 x plus 8 minus 5 equals 3. Okay, so same thing, the operation. What are we going to do? How do we solve this? Say we're going to put 3 in for x. So first thing we would have to do is multiply, right? Okay, and then and the inverse would be divide. Second is we would add 8. Oh, actually, shoot. Think about that. Well, wait a minute. Let me check that back. My fault, guys. I didn't do the first step right. Okay. Let me do that again. So after dp, now what can we do? So we have like terms here. We have this one is a 5, and this one's a 5 and 8 are like terms. So that's CLT. Okay, CLT. So I'm going to write that down. So that's CLT's next. And that's NA because it's not applicable to the inverse of that. So if I do CLT, I'm going to get negative 2 x, and I'm going to have 8 minus 5, which is 3, plus 3. Okay, equals 3. All right. Now, what do we do next? in this situation. Okay, so again, if we plugged in a value for x, what we would do? We'd multiply by -2. So we'd multiply is first thing. The inverse of that is negative. Next, we would add 3. So that would be minus. Okay, and then we're done. So let's think of let's go from bottom to top. So the first thing is we're going to do for the inverse side is -3. Okay, let's get 3 down. Oh, sorry guys. Pixel control. I'm gonna get better. I swear to God, I'm gonna have to break down and buy the Adobe Reader to make this cool, make this better. But I don't want to spend that money yet. Almost there. Okay, so that would negative, and this would become 3 minus 3, so that would become boom. That would cancel as well. So all of a sudden, now we have -2 x equals 0. Okay, so now what can we do? Now this next thing is we divide by 2. So we're going to divide by -2. Divide by -2. Divide by -2. Okay, so once we divide by -2, 0 over -2 is equal to 0. Okay, and that would be the answer to the question. Once we get into some harder stuff, we're going to start talking about identities and solutions. And once we start working with these things, and so once we get to both sides of equations, we'll start talking about identity and solutions as well. And that's how we're going to end it for this term. Okay, so that would be the answer to that question. Now let's look at the last one here. Okay, so the first thing we would do is distributive property, right? For this one. Okay, so let me get this thing back. Hold on. Come on, baby. There you go. Okay, so this one I would distribute. Now, looking at this though, I have 1/2. If I distribute a 1/2 to -3, and then my 1/2 to 3x, I'm going to get 3 over 2. That's going to be a weird number here. So that's kind of hard. So this technique we're going to call R, which is reciprocal technique. Okay, it's going to be reciprocal technique. So what I'm going to do is, instead of just multiplying the whole thing by 1/2 in the parenthesis, what I'm going to do is I'm actually going to multiply the first number by its reciprocal, 2 over 1. Okay, reciprocal means opposite, or flip it. So I'm going to flip the 2 over 1. I'm going to multiply this by 2 over 1. And like I said, the inequality means I got to do the same thing on the other side. So let me do this on the other side, 2 over 1. Okay, so now I have 2 over 1 over 1/2, that cancels. So that ends up being a 1. So I end up with 3 plus 3x. Now I got to do 18 times 2, which gives me, boom, which gives me 36. Okay, 36. Now, after that, now what do I do next? Okay, at that point, after I do the reciprocal. Now again, remember there's no inverse to that. So I'm going to write NA for that. Next, I almost did it for you, but we're going to -3 from both sides. So we got to do we got to add 3 in the inverse. And then last part, wait a minute. Sorry, I messed that up. Sorry, guys. No, I want to add, I'm trying to just go ahead. I'm sorry. I got to be slow. All right. So again, I'm going to do, first thing I want to do is if I plug the value in for x, I'm going to have, and I say it was 3, it's going to be 9. So I'd have to multiply first. So the inverse of that would be division. Okay. And then the other portion is I have a negative. I would have to, a -3. I have to go through a -3. So I add 3 to both sides. So again, now I'm going to do the inverse techniques. Okay. So first thing is I'm going to add 3, both sides of the equation. That's going to cancel. Okay, so I end up with 3x equals 39. Okay, now from here, what do I do? Now it says, now I say divide, so I got to divide by 3. Divide by 3. Divide by 3. So that would give me x equals 13. And that would be my answer to the question. Now, I could check that if I want, and I plug in a value for x, and that would check the answer for me, and that's how it would work. Boom, I'd be done. Okay, and that's how it would work. All right, so those are the 3 questions. I have a couple more to show you. I'm going to show you one more, and then, like I said, we'll move on, and I'll get you guys to do some work because I'm probably tired of hearing me talk. Okay. Last one. Oh, wrong way. Last one. All right, so I'm going to show you the reciprocal technique again. Okay, so this one, again, we're going to use the reciprocal, R. Okay, I'll show you that technique again. All right, so I got a 2/3 here. If I distribute the through, I'm going to get 2/3 x, and I'm going to have to do 2/3 times 4. That stinks to use. So what I'm going to do is I'm going to multiply and take the reciprocal, flip it, and I'm going to do 3/2 on both sides. Oh, God. Sorry, guys. This is bad. So I'm going to multiply by 3/2. Okay. So once I do that, this cancels, and that becomes 1, so that's done. So it becomes x minus 4 equals, and then all I have to do is cross cancel here. So I have a 2 and I have a 16. What is 2 and 36? What's that? 18. So again, this becomes 18. If I cross cancel, this becomes 18. Okay, and this becomes 1. So then becomes 18 times 3, which becomes 54. Okay, so what do I have to do now? I add 4 to both sides. And I end up with an easy question of x equals 56. 58, actually, sorry. And that would be the answer to the question. Okay, so again, it's a different way of doing it with reciprocal. Okay, but it also takes away any type of fraction involved there, and then so you don't have to do distributive property, and then you can actually solve it. I think you can solve it quicker. Okay, but you got to be good with your fractions and understand reciprocal to do that. I was going to show you how to do it without with the fraction here, but I'm going to leave that alone, and we'll just have you practice on these type of problems. Okay. So that's it for today. Again, hopefully you can get that information and start working on that and do great in the class today. And I'll see you all later. Bye now.